Okay, another exponent or rule that we need to discuss is the power rule. So taking an exponent and raising it to another power is the one that we're going to focus on today. And what happens here is when we take x raised to the a power raised then again to the power of b, we multiply those together. And so here's kind of what happens here. So let's just say that we have x squared, and that's squared again. So if you remember, x squared is x times x, okay? And then to square something means to take that and multiply it by itself, x times x. So what happens here is when I have x squared multiplied by x squared, I get x times x times x times x, or x to the fourth, where we've taken and multiplied those together. Now, probably not the best example, but if we change that 2 to a 3 here, so you can see it even better now, we take that x squared, multiply it by x squared, and multiply that by x squared. Well, now we have x times x times x times x times x times x, which is x to the sixth power. And so now we can see how that x squared raised to the power of 3, we multiply 2 times 3 is the 6, okay? So that is kind of how that power rule works. So for example, if I had, let's see, number 2 here, m to the 9th power times n to the 5th power, and all of that is raised to the 4th power, we take that 9 and multiply it by 4, and we get 36. And we take that 5 and we multiply it by 4, and we get 20. So we end up with m to the 36th power and n to the 20th power. Definitely don't want to have to write all of that out like this, which is why we use the power rule. Okay. Now, if coefficients are involved, we raise that coefficient to that power and then simplify using that power rule. So for example, 2 raised to the power of 5 is 32. X squared raised to the power of 5 is x to the 10th power, 2 times 5. And y raised to the power of 5 is a 1, remember it's an understood 1 there, times 5, which is y to the 5th power. So 32x to the 10th power, y to the 5th power. One thing you want to be careful about these is when you have a negative that's being raised to a power. Remember, that's negative 5 times negative 5 times negative 5 times negative 5, and so when we multiply two negatives together, it becomes a positive, but then we take that positive and multiply it by another negative, you end up back with a negative number, so you got to be careful about this. So if your exponent is odd, this number is going to remain a negative. But if this number is even, it's going to change to a positive. So negative 5 raised to the power of 4 is 625 positive. M to the 6th power raised to the power of 4 is m to the 24th power, 6 times 4, and n raised to the power of 4 is n to the 4th power. And so all of those are multiplied together, even though there's kind of a space there, it's not meant to be. They're all multiplied together, and it's still one monomial term as our answer there. So same thing happens here. You would just use 1/2, raise that to the power of 3rd, to the power of 3, it becomes 1/8. A cubed raised to the power of 3 is a to the 9th, 3 times 3. B to the 4th power raised to the 3rd power.
Teachers, please for interruption. I need to see Challenge Smith.
Sorry about that. Interruption there. 4 raised to the power of 3 becomes b to the 12th power, and then the 5th power raised to the power of 3 is 15. Okay, so we end up with 1/8 times a to the 9th power, b to the 12th power, c to the 15th power as our final answer. Okay, so again, kind of taking what we've learned with addition, subtraction, multiplication, and now the power rule, we can kind of incorporate all of that into our work here. So looking at let's look at number 11 here. R to the 4th power multiplied by negative r to the 7th power multiplied by s, and that's all raised to the 3rd power. So what happens here on these is we have multiplication and we have an exponent. So order of operations takes into effect again, and we're going to take care of the exponent first. So we're going to take that negative r to the 7th power and s, and we're going to raise that whole thing to the 3rd power. So we got to do our coefficient first, and even though there's not necessarily a coefficient here, there really is. It's a negative 1. So negative 1 raised to the 3rd power remains a negative 1. Then r to the 7th power raised to the 3rd power becomes r to the 21st power, and s raised to the 3rd power becomes s cubed. Okay, so we end up with this. But then that, once we've done the power, now still has to be multiplied by the r to the 4th power. And so the negative 1 multiplied by this 1 becomes this understood coefficient of 1, becomes a -1. R to the 4th multiplied by R to the 21st. Well, now we're doing multiplication, so don't get tripped up and multiply these. Now, because we're multiplying, not raising them to a power, we're going to add those exponents, so it becomes R to the 25th. And then there's no S to multiply it by over here, so we're just going to bring down this S cubed. So we end up with negative R to the 25th power S cubed. Okay, so there's a lot to remember and a lot of rules with the exponents, so you want to make sure that you definitely take time to discuss or to think through each of those rules as you're going through your steps here. Okay, so another example would be like number 15, where in this case we have a monomial being raised to a power, so that's an exponent. We also have another monomial being raised to a power. We have subtraction and we have multiplication, so we need to do our exponents first. So let's start there. 3 raised to the power of 4 is 81. X cubed raised to the power of 4 is x to the power of 12. Y raised to the power of 4 is y to the 4th. Minus 7 squared is 49. X to the 5th squared is x to the 10th. Remember, we're multiplying 5 times 2. And y squared is y squared. Multiplied by x squared times y squared. Okay, so now we have subtraction and multiplication, so we need to multiply next. So we still have 81 x to the 12th, y to the 4th. We have a negative 49 multiplied by this understood 1 coefficient, so we can just bring down that negative 49. X to the 10th multiplied by x squared is going to be 10 minus 2, which is 10 plus 2, which is x to the 12th. Okay, remember, because we're multiplying, we're going to be adding those exponents. It's easy to get tripped up if you're not careful. Y squared times y squared becomes y to the 4th. Okay, now we have subtraction. When we subtract monomials, we don't change anything with the exponents or the variables. We have to make sure that they're the same, which they are, x to the 12th, y to the 4th, x to the 12th, y to the 4th. And all we do is combine our coefficients. So 81 minus 49 becomes 32, x to the 12th, y to the 4th power. Okay, so a lot of steps, but just take it slow and go through your order of operations and make sure you're using your exponent rules as you go. Okay, so geometric applications. What does this mean and how do we use it? So it can be used in geometry, which is something that you will see probably when you get into geometry, but just kind of a taste of what that looks like would be this here, where we're asked to find the perimeter and the area of each figure below. So you may have to look up, as we're working through these, some of your formulas. That might be a good idea here. But you've got a rectangle and two triangles here. So we're going to do number 16 together. So perimeter here is 2 times the length plus 2 times the width. Okay, here's our length, 12x, plus here's our width, 2 times 5x squared. And remember, perimeter just means adding all the sides together. There's 2 lengths and there's 2 widths. So we're going to simplify this. So p is equal to 24x. We just multiply that. 2 times 5 is 10x squared. And then what happens here is we have an x and an x squared. They're 2 monomials, but they have different variables and exponents. So they are not like terms and we cannot combine them. So we leave our perimeter just like that. Now area, we know, is length times width. And so if we multiply that out, we have 12x, our length, multiplied by our width of 5x squared. So now we're using the multiplication rule. So 12 times 5 becomes 60. X times x cubed, we add those together, it becomes, x times x squared, when we add those together, it becomes x cubed. Okay, and so that becomes our area. So now we have a perimeter and an area. So keeping with that, you're going to use your formulas for area and perimeter of triangles to do 17 and 18. Okay, now it gets a little bit more challenging when we start working with circles and with trapezoids, but again, this is just asking for area, so you're going to find your area formula for trapezoids and for circles and plug in those values that that you have and just simplify them. Notice that there's not a specific number of value for the perimeter and the area, just an expression, and that's perfectly fine. Until you know what x is, you're not going to have an actual value for those areas and perimeters, and that's acceptable. Okay, so make sure that you look up those formulas. You can use those to solve these, but you're just plugging in these values and using these rules, exponent rules that we've been discussing over the last couple of days to work through those.